Okay, now we create our scenario. So right click on the scripts folder and create a new folder named scenario, and in there create a new script and call it scenario. Then open it up. All we're gonna do here is to create a new instance of our ground, which we create later. And in the start function we initialize the randomizer and generate our ground. And for testing, we regenerate our ground in the update function. Then we create our ground script and open it up. First, the ground needs to be serializable because we want to edit the properties in the editor, and it's a simple class which extends nothing. We need a width and a depth, and we have multiple regions which we create later. We're gonna use simplex noise for the regions, so we need an offset and a scale value for that. And since we have an 8x8 tile texture, we need to set these columns and rows. And we also need to store every tile in a two-dimensional area of ground tiles, which we also create later. And then we need to create the mesh, so we also need the mesh data object, which we also create later. Then we need a game object for the ground, and this game object contains a mesh filter and a mesh renderer. Then we are going to create the ground object, so we create a new game object, name it ground, and add the mesh renderer and mesh filter component to it. And the mesh renderer gets the material which we defined before. In the public void generate function, which we call in the scenario, we just create the ground object and call the regenerate function. The regenerate function initializes the ground tile array with the width and the depth and create a new mesh data object. Then we loop through the width and the depth and create every ground tile and the mesh data for it. In the create ground tile function, we just set the position to a vector3 object, and we are going to get the region for this position. The getRegin function gets a position and adds our noise offset and multiplies it with the noise scale. To get our region index, we generate the noise value and multiply it with the count of our regions. And then we just return the region with its index. Back in the create ground tile function, we create a new ground tile with the position and the region and save it in the array. In the add ground tile mesh data function, we need to get the UV chords in the get ground tile UV function. We have the current position of the current ground tile, so we can get this ground tile and get its region. In the region is a variable named texture row, which defines the current row in the texture, and the current column is a random value between 0 and the tile count, which is also defined in the region. In the getGroundTile UV size function, we calculate the size of one single tile in the texture, and since we have an 8x8 tile grid, the size of one tile will be 0.125f by 0.125f. Back in the getGroundTile UV function, we need to calculate the current UVX and UVY position and return it as a vector2. And back in the add ground tile mesh data function, we create a quad in the mesh data object, with the current position, the UV start and UV size. The next class is the region class, so we create a new script called region and open it up. The region is also serializable and is also a simple class. In there we just have the current texture row as an integer and the current tile count. Next we need the ground tile class, so create a new script and open it up. The ground tile is also a serializable simple class. It just has the current X and Z position and the current region. In the constructor we just set its values. Now we need the mesh data class. So create a new script and open it up. It has the vertices, the UVs and the triangles stored in lists. In the constructor we just initialize the lists. In the createQuad function, which we use in the ground class, we create the vertices, the triangles and the UVs. In the createVertices function, we just add the 4 vertex points to the vertices list. In the createTriangles function, we add the triangle positions to draw our 2 triangles. In the createUVs function, we add the current UV coords to the list. In the getMesh function, we just create a new mesh and return it. The overloaded function getMesh just clears the mesh, adds the vertices, triangles and UVs to it, optimizes the mesh, recalculates the normals and returns the mesh object. Okay, now we need to create a new game object, name it scenario, reset its position and add the scenario component to it. Set the width and the depth to 30 and for now just add one region to it. Set the texture row to 0 and the tile count to 5. Set the noise scale to something like 0.15. Now create a new material, name it ground and drop the texture to the albedo channel and set the source for the smoothness to albedo alpha. And the smoothness to 0. Then add this material in the scenario object to the material variable. Next we need our instance of the randomizer, so add it to the scenario object. Then save it up and run it. Now you can play around with the settings, add another regions till you have a setup which you like. Then click on the settings button of the scenario component and copy the component values before you stop the scene. Then hit stop and paste the component values. Alright. we have our working scenario. Next time we create our enemy lanes.